So today, just make sure this absolutely works. Yep. All right. Looking good. Today we're going to get started on actually looking at the material rather than just getting you set up. You went through your lab yesterday. Everybody completed at least the C lab, and a substantial number of you completed also the Java lab. It's basically the same process that you'll be handing stuff in throughout the entire semester for all labs, for all hacks, and even your exams eventually. Remember that we are on Piazza and we are on YouTube, so if you have any questions or if you're watching online, then go ahead and ask there. But before we get into the basics of variables, variable types, operators, and input and output, I wanted to get a little bit more of an appreciation for what that code compiling process was all about. Because when we write code, and here's an example of some code here, don't worry about the details, we'll go into it later here. You can read up here that it converts it's a program to convert miles to kilometers, right? Now this code is meant for human beings, right? This is not something that a machine can understand. When you start out with code like this, it's written at not the high level of English, right? Again, we're not in Star Trek fantasy land where we can just tell a computer exactly what we want to do using natural language, just plain old English or whatever your native language happens to be. Instead, we have to have something in between, right? We don't also, in fact, in the early days they did, you don't want to have to write stuff in a bunch of zeros and ones, right? You don't want to have to punch those punch cards and for the zero and leave it blank for the one or whatever. So you needed something in between. And so what initially was developed was called assembly code. Assembly code is a set of instructions that can actually be run on a processor. So to show that to you, let me go into my folder here. Where am I? Lecture CS155H. There we go. All right, so I've got this file here, and we're going to show the process in C first. I'm going to go ahead and compile it like we did yesterday, or like you did in your lab. And that's just a one-shot process. There's a lot going on behind the scenes here. What's going on behind the scenes is an entire sequence of events. That we are taking a plain text file and we are translating it into an executable file, something that can actually be run by on a computer, right? But it starts at a source, then it becomes assembly, and then it becomes machine code, right? That process is completely opaque by me running that one command GCC. What I want to do is I want to run you through each one of those steps. You can do it manually if you want to, right? So for example, what I'm going to do is I'm going to go ahead and convert this into assembly using GCC and this special flag here. You won't use this at all in the course. I'm just using this as a demonstration. If I assemble, or if I compile that to an assembly code, it produces another file. This miles to kms.s, right? And that's just short for assembly or something like that. What does that file look like? It's certainly not machine code yet because it's not a bunch of zeros and ones. But you can kind of read it, but it's way less readable than, say, the C code over here, right? If you walk through the C code here, we're creating miles and kilometer variables. We're printing out a message to the user. We're reading in the input because that's what the comment says. We're computing however many kilometers it is, and then we're outputting the result, right? Can you necessarily follow that with this? No. But some people do write assembly, and eventually you will write assembly directly. But that's what you had to do back in the old day where you didn't have a high-level programming language like C. Right? So source becomes assembly, and then assembly becomes machine code. Let me go ahead and show that to you. I'm going to, oops, not that. I'm going to use this other flag called, these are flags, hyphen, and then a letter or a variable or something tells it to do something a little bit different. You're basically passing in options to the compiler. And the C here is going to be compile it, but do not produce an executable file. And so let's go ahead and take a look at what that looks like. Miles to C, there we go. That produces this .o file. That .o file is an object file. An object file is basically machine code, but it's not executable, right? When you actually compile this, you created an executable called a.out. That's not what this file is. It's just a bunch of pure machine code that is not runnable. If I try to say, list it, let's go over here, and it's not even going to let me do it because it appears to be binary, right? Open it anyway. I wonder what it'll look like. Oh, okay. I have to find an editor or something, right? I can't even more it at the command line here. More is a utility that says print it out to the standard output here in this terminal, and it's not even going to let me do that because it's not a text file. I can, however, use a utility called hexdump. Right? Hex is short for hexadecimal, right? So computers are binary, zeros and ones. We humans are decimal, right? Why? Because we have 10 fingers and 10 toes, right? You can count in any base, 2, 3, 4. If you count in base 16, that's hexadecimal. That's going to be 0 through 9, and then A, B, C, D, E, F, right? Because you need 16 characters or 16 symbols. And counting works exactly the same in any one of these systems. So I'm going to go ahead and go with hexdump. Tell me what hello, or not hello, but miles to kilometers.o looks like. All right, there we go. That's what it looks like. Right? Now, some of it is readable. Miles to printf, ISOC 99, scanf, ... But most of it, and my message is like, please enter miles. Right? That was plain text in the program itself, and so that's preserved in the program. Right? But most of this, all this ... is just a bunch of machine code, a bunch of zeros and ones that only a machine would understand. Okay? There's a lot more going on there too. There's optimization. There's what's called linking. Right? For example, we brought in a couple of libraries here. We brought in the standard library, and we brought in the standard input-output library. Right? Those are not my code. Right? You see them. You don't see them anywhere here. Right? They're in an object file somewhere else on the system. So when I've got my kilometers or miles to kilometers.o object file and the standard input-output library.o file, those still have to come together to produce that a.out file, that executable. That's called linking them together. So there are a bunch of other steps. I'm greatly simplifying the process here, but I wanted to show that to you just so that you have a better appreciation of, we have high-level source code here, right? C is a high-level language, right? It allows you low-level access, but it's still a high-level language. Java is the same way, right? Similar but different. You start out with a bunch of source code. It does not get compiled into assembly code nor machine code. It goes somewhere in between, right? Up here, plain old English. Then down a little bit lower, we've got programming languages. And then down here, we've got binary. Somewhere in between is called Java bytecode, right? Where it's not compiling for this machine right here, or whatever AWS machine is running this thing over here. It's not being compiled for Ubuntu. Instead, it's being compiled for the Java virtual machine, right? Let me come over here. If I were to compile that other program, or even your Hello World program, for Ubuntu over here, right? I could not take that program and move it over to Windows and expect it to run. I couldn't even take it over to a different version of Ubuntu and expect it to run. But with Java, since it compiles to this Java bytecode, I can take it anywhere that there's a Java virtual machine, and I can run it there. Right? It's a compile once, run anywhere language. Right? There's something under the hood called the Java virtual machine that it is completely opaque to you because you're just hitting this play button here. Right? But I did want to show you what it looks like on the system. So let me go ahead and right-click this and go down to Properties. Everything is just being stored as a file on here. The IDE is nothing more than a magic front end taking care of all the stuff behind the scenes, behind the curtain. If we actually take a look at the files here, here they are. I've got to bring, it's on my other screen, so I'll bring it over here. Right? There's the project that we've just created. There's a bin directory and a source SRC directory. SRC, we've already seen that. That's source, right? So if I open that up and I look at, remember that what we've got over here, we've got a package called unl.cse, and within that we've got a helloworld.java file. Right? There it is, unl.cse, helloworld.java. And there is the file that's living on the file system. Right? If SRC stands for source, what do you think bin stands for? Binary, right? And we have the same structure. Everything in Java is organized under packages. Packages are nothing more than the directories on your file system. UNL, CSE, And we've got this other thing here called hello world.class, right? Now, if I were to try to double click this, it's not going to run. If I were to try to do anything with this, it's not going to run because it's compiled for the Java virtual machine. I have to take it and run it on this virtual machine. Let me show you what that looks like. From the terminal, just like I was doing for the C stuff, right? I can see that there's this hello world.class file, right? So I can run it by running Java. And again, you don't have to worry about any of this because you're going to be using Eclipse. If you want to get down practice on the command line, go ahead, be my guest. It's fun. Java class path here, and we'll run unl.csc.hello-world. I'm just telling it the CP is for class path. Find it right here and run this thing. I think, hopefully this will work. Nope, okay. I'm going to have to go up a couple more. There we go. And then run the same thing. Yep, there we go. Right. It couldn't find it because it was expecting it to be in UNL-CSE, but I was already in there, and so I had to go back out so that it could find UNL-CSE, then hello world. Right. What does it look like from the command line? Here I'm not as restricted. UNL-CSE, hello world. What is in that file? Right. It's a binary file. See it anyway? Yeah, let's go ahead and take a look at it. What is it? It's a lot of binary, but it's binary Java byte code. Right? A lot of it is still plain old English here because it's half compiled. Right? C is a completely compiled language. It is compiled for that machine and that machine only. If you want to run it on another machine, you need to take that code, move it to that machine, use a compiler for that machine, and then you can run it. Java is different. Java is compile once, take it and move it to any machine. As long as you've got Java installed, it'll run. Now, it's not necessarily true that, say, 2022 Java can be run on a virtual machine from 20 years ago. It's not necessarily backwards compatible like that. But they've gone to great efforts to ensure that backwards compatibility is preserved. Right? We can actually not decompile it. I don't have a decompiler here. But you can decompile Java, by the way. Return it to its original source. It's not going to preserve the entirety of the original source, but it'll be pretty close. I don't have a decompiler here, but I do have a tool called Java P that will tell me what's in. Get rid of all that binary and tell me what's in that file. Well, it's a class called Hello World, and you've got this function called main. Right? It's not telling me the contents of that because it's Java bytecode. Right? That's the binary stuff. The garbage. I just wanted to show that to you so that you get a better appreciation of it ain't all magic, right? This play button is taking care of a lot of the grunt work for you, but there's still grunt work going on behind the scenes. Right? Okay. So that was a little bit of a demonstration. And again, Java is not purely compiled language. It's compiled to a Java bytecode. There we go. Does that render now? Okay, there we go. Bytecode is then interpreted by the Java virtual machine. If you want to, I usually skip the history of both of these languages, but C is well over, almost approaching 50 years old. Java is 25 years old, so it came far later and attempted to fix some of the, that's what every language does. They try to fix the problems with all the other languages, right? But then that just creates different problems. Java actually was created originally for cable-top boxes, right? What you would think of as a Roku today, a completely programmable cable-top box, that was their dream in the early 90s, right? To have those things and to have a language that you could program stuff on for those things. And it never really manifested itself back then. Java itself, the language itself, became popular enough that it's still used today, right? C, Java, those are going to be in the top 5 languages of today and probably for the next 20 years or so. If you want to add on to that, eventually your skill set should expand out to probably C#, Python, JavaScript. If you've got those 5, you've got 95% of the job market out there. PHP maybe, if you want to get into legacy code. Right? All right, so let's take a look at this program and start identifying the anatomy of this program here. Right. So let's start at the top here. What do I have right here? This is just an author header, right? Just like an English paper, what do you put into the top of your English paper, your 5-paragraph essay? Right? Your name, your date, and here there's the purpose of the program. Right? In your beginning programs, when we say documentation and we grade on documentation, since the programs are simple enough, that's what we mean for now. Right? Later on, we'll get into more sophisticated documentation. Right? So we've got comments here. Syntactically, what do they look like? This one is a multi-line comment, right? So I've got is that a backslash or a forward slash? Forward slash star, and it ends with a star forward slash. Not a star forward slash, or space forward slash. It has to look like that. Now this extraneous star up here and all these vertical stars, that's called doc style commenting. And I encourage you to use it. You don't have to use it. It's just a regular multi-line comment here. But if you get into the habit of using that stuff, then what you can do is you can use tools to auto-generate documentation. This is why it's called doc-style comments. If you use that style of comment, you can actually link your comments to other documentation and other parts of the code and make cross-references and stuff like that. If you do it in Eclipse, it's even automatic. If you just go /*, it knows, oh, you want to make a doc-style comment. Hit enter. Right? It'll even start filling in the blanks for you. Right? For example, if I did that on this function, it would have this parameter here called args, and then I could document that. The command line arguments. Right? And I could go ahead and put in, there's the author, right? This @ sign here. And that was automatically generated by simply looking at the username on the system. But the doc-style comments are great because not only can you put in the boilerplate stuff of author, date, purpose, right? You can also add in other things. The first hello world program was written in, I don't know, Fortran? I have no idea if that's true or not. C, and then what I'm going to do is I'm going to link to an external article on Fortran here. And for that, I'm going to have to find a Fortran Wiki Pdf. There we go. All right. There's the link there, and I'm going to put the link here. Anybody know what this is right here? This gobbledygook? It's HTML, right? It's a link. This is an A and then a hyper reference to this website right here. It ends with this closing tag A, and this then becomes a link. Right? Oh, that's all still code, right? It's not even readable. But if you ran a documentizer, whatever we want to call them, right? It would look like this. And unfortunately, I can't zoom in there, but I can click that link now. If I do that in Eclipse, it'll launch its own browser too. Right? But you can cross-reference and link between different documentation, external links like this, etc. Right? Again, we're not going to require doc-style comments, but you should get into that habit of using this formatting. Right? Again, for now, all we're looking for is for you to document your author header for now. When we get into actual functions and methods, every function, every method will have to be documented. When you get into multiple classes in Java, eventually towards the end, then each class needs to have its own documentation. Okay? What's next? What's that stuff? Yeah. Libraries, right? You don't start from scratch, right? Imagine if you had to write everything that defined an integer, right? Or everything that defined printing to the screen. Okay, I have to write this code to make sure that this pixel is filled in and that this pixel is blue and that I've got anti-aliasing everywhere, et cetera, et cetera. You don't start from scratch. Instead, you bring in external libraries. Include stdlib.h and include stdio.h. Don't worry about the formatting just yet. We'll talk. This is actually what's called a preprocessor directive. We'll get into that later on. Just know that all of your programs, if they're going to do any input-output, you need the IO library. All of your programs will need the standard library. It's so standard that most compilers will automatically link it in for you, but it's still best practice to include this here. Right? What does that look like over here in Java? How do I include things in Java for those with Java experience already? I don't use the include keyword, do I? No. I do what? Import. All right, so I don't know. I don't know where it is. Let's go ahead and have a scanner. S equals. All right. Java.util. There we go. Let's come back up here. There is a typical declaration of bringing in an external library, right? Now, there are lots of things in Java that are brought in automatically, like the standard library in C, right? You don't have to define what an integer is. You can just create an integer, int a, and you're good to go. Why? Because the compiler brings in everything under a package called import java.lang, right? It already brings in everything in that package. Java, what does lang stand for? What do you think? Language, right? Everything that's part of the language is in that package, and it's automatically brought in. You don't have to use that. Right? What things besides input output might we want to bring in instead of having to pull out our TI-82s all the time? I asked this before in another class. Do they still have required graphing calculators in calculus? Okay, good. Well, yay, it's 2022 already. Okay. All right, what do they require instead? Do they let you use their phones? No? How do you do stuff then? The what?
Like GeoGebra, like
Okay,
programs.
so they let you use a computer.
Yeah.
All right, you can use that app on your phone probably, right? Just not during an exam, maybe. I don't know. Whatever. Anyway, what would we want to bring in so that we don't have to bring out our graphing calculators and compute sine, cosine, square root, things like that? Include in C, it would be the math library, right? Once we bring that in, then we've got access to all these functions like tangent, sine, arctangent, et cetera, right? Without that, then it's not being brought in. If I wanted to do some math over here, what would I need to do? Math dot square root, right? Now I don't, square root of 0 is 0, negative 1, right? There we go. That's computing the square root. What's the square root of negative 1? I. There is no I in programming. Instead, what do you think that the result is? Undefined, not a number, right? We'll find out later. Right? But otherwise, I didn't need to bring that in. Why? Import java.lang.math. That's where it is. In fact, I can go to it. Right? Here's an Eclipse trick. If you want to go to a different source file, all you have to do is, at least on Mac, it's going to be command, hold that down, and things become clickable. Right? Windows users, what is it? I imagine control, and then it becomes clickable, something like that. I can take a look at what's in the math library. For example, they've defined E to be 2.71 blah, 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 blah. They've defined pi to be this thing, right? Same thing over here in C. They've defined pi to be in this math library, and it is called m_pi. Right? You don't have to define your own pi. You shouldn't define your own pi. You should use the math library's pi. Okay? We'll get into the math more later on. What's next? We've got this define here. Now, I'm not going to jump over to Java and cover this because, well, I will in a sense, but it's going to be completely different. Everything up, you see the parallel so far, right? If I've got comments here, I've got comments over here, not here, comments over here, right? Exact same formatting, exact same syntax. By the way, before we go on from comments, what other kinds of comments are there? Single line comments. Line comments. Right? You can put those on a single line, this too, right? And everything after that, as the green indicates, means that it will be ignored. You can put it after code, but you can't put code after it, right? So int a is equal to 10. That's still just a comment, as the green attests, right? So what is the purpose of comments? One, It's to document things, right? The what is this and why was it written? This is a program that converts miles to kilometers. It was written by me a year ago. To the date? No, as of tomorrow. All right. Well, there, I wrote it today instead. You could put copyright notices in there, right? That's another usage. But let's jump down here and look at the single line comments in this program. Right? What is the purpose of that comment? Prompt the user for input. Yeah?
So if someone's reading the code, they know what it's for?
Good. It's to communicate to other humans, right? The compiler, the machine, they ultimately ignore this. It's plain English, right? This is our only glimpse of that Star Trek world where we can put in plain old English and communicate to other humans for other humans, right? This right here basically does the same thing, but in machine form, right? Print F, please enter miles, right? Now, we're just getting started here. So this kind of comment is appropriate for a demonstration to show you that this is what a single line comment works. After the first couple of weeks, we should not see comments like that. Why? After the first couple of weeks, you should know what a printf does. Right? That comment is self-documenting. Anybody who is competent in the language should be able to read that one line of code and know what it does. Right? You do not need to read it twice if you know what you're doing. We don't want to see those kinds of comments. We want to see comments that tell you the why. Why did you write this program? Well, I wanted to convert kilometers to miles or whatever, or miles to kilometers. Right? Now, if something is really super complicated and you've got like a chunk of code that is 10 lines and it implements some Taylor series numerical interpolation method, right? Then, of course, you need a comment there that says this block of code does the Taylor series method, blah, blah, blah. By the way, you can read more about it here. Here's a link to the paper. And also, we chose this. Why? Because it has nice convergence properties, or it works on this particular system, right? You are documenting your code and telling not only other people, but also your future self why you did it this way. We did it this way because the client had business rules that dictated that they could not sell pizzas on Sundays or something like that, right? Just weird stuff. Why would anybody do that? That's the purpose of a comment. Right? It's not to document every single line of code. If I went through here and I documented every single line of code, this line of code converts the miles to kilometers, right? No, I mean, you can read line 23 right there and understand that right away, right? A mile is a unit of distance equal to 5,208, is that correct, feet, right? Is that an appropriate comment? No, it's completely extraneous, right? It muddies up your code. It's what we call cruft, right? So C-R-U-F-T. There's a nice word, cruft. Right? So I don't know if it's Harvard or if it's Stanford or somewhere else, but there used to be this building on one of those campuses that was unused. Classes weren't held in it or whatever. And so anytime somebody had like a broken projector or a piece of equipment nobody wanted anymore, right? Instead of properly disposing of it, they would throw it into Cruft Hall, right? Eventually the entire place filled with garbage, right? And it became known as Cruft, right? Well, that's Cruft, that's garbage, it doesn't belong there, right? So, what do we do with garbage? We throw it away, right? It's Cruft, it's extraneous, it's pointless, it's useless, it's just adding lines of code to add lines of code, right? Don't do it. But I will leave these here because I want you to see what a single line comment looks like, right? Okay, let's see, what else do we have in this program here? What's next? Well, here, sorry. This was what was next. So, ignore the first two parts and look at 1.60934. Right? What's that number?
Kilometers per mile.
Ah, but you looked at the first part, right? So, if you'd only seen that, if I came in today and didn't even tell you that we were going to convert miles to kilometers, and I told you, here's an important number, 1.60934. Would you know what the hell that means? Right? Now, some numbers like 3.14159, what is that? Pi, right? Or it's almost pi, it's a pi out to 5 digits, right? 2.71. E, all right? 0.908762. I just made it up, right? That's what we call a magic number, right? If you've got a number that's just sitting out there, it's a magic number, it's a mysterious magic number. What does it do? What is its purpose? What is it modeling, right? Well, you read the first part, KMS per mile, right? We gave it a label. We gave it a human-readable label, right? We could have written a comment that said, oh, by the way, throughout this program, we're going to use 1.60934. That's the standard unit of measurement for converting. That's the number of kilometers per mile, right? But what would it look like down here? Later on in the program, we would have to use it again. 1.0, what was it again? Oops, I screwed up. Right? Imagine you use that number in 50 different places, 100 different places. What is the probability that one of those digits will be screwed up? Very, very high. Right? Whereas if I use what this is called a preprocessor directive, I'm defining KMS per mile to be this number. Let me undo that. Right? If I define it in one place and I want to add more accuracy, I have no idea if this is more accurate or not, but if I want to add significant figures, I'm doing it in one place instead of 50 places. I have one definition of pi in the math library, not 10 different definitions. Sometimes pi is 3.14, sometimes it's only 3, right? Et cetera, et cetera. So that's a nice way of doing that, by having a preprocessor directive. Now, literally what happens is the compiler comes in, before it compiles, it pre-processes your source code. And it does a cut and paste. It says, okay, KMS per mile, anytime I see that, I'm simply going to replace it with that number. But it does it automatically. It keeps your code readable, and it takes care of all that grunt work for you. Right? The equivalent over here in Java would be, collapse that, collapse that. Let's just go ahead and get rid of this and start our own KMS per mile here. Class. Or miles to KMS, right? Miles to KMS. That's, and I don't put Java there. Note there the naming difference. Capital M, capital T, capital K, right? That's called upper camel casing conventions, and that's the convention you should follow for all class names in Java, right? All right, let's go ahead and add our main. Actually, no, we'll do this progressively as we go through. So I should document this program, right? There's the author, me. Date would be 2022, 08/24. By the way, I don't know if I said it the other day, but that is the only correct way of writing dates. Year, month, day. Why? Europeans are wrong. Americans are wrong. Computer scientists are right. Why? It's what? Biggest to smallest means that it is now sortable, right? And as long as I have leading zeros here, I can just sort dates automatically using this format. Those other formats, they'll be all over the place. Right? This is called lexicographic formatting, and there's a nice standard for it, ISO 3306 or something. I forget what it is. But that's the correct way of doing it. Right? Get into the habit. Sign all of your documents with the correct format, and call other people out when they don't do it. All right. Public, static, void. Oh, no, sorry. Where are we over here? We don't have to bring in anything just yet. We're not doing any sophisticated math. But I do want to show you the equivalent over here. Right? So public, static, final, double, KMS to, in fact, what was it? I don't want to cut and paste the entire thing. There we go. There. And I have to set it equal to that thing. Right? Now, don't worry about those keywords. If you already know what they are, great. Public just means that any piece of code can see this variable. Static means that that variable belongs to the class. There's only one copy. Right? Final means that it is final. Right? You cannot change it. If we went back to that math library, I don't want to go back to the math library, but if we looked at pi, if you saw it, there was a final keyword in front of it. That's so that you can't go and change pi to be 4, right? It was defined to be 3.14159, et cetera, et cetera, et cetera. Any attempts to change that will be a compiler error and it won't compile. I'll show you what I mean by that here in a second, once we have our public static void main string args. What if I wanted to change KMS to mile to be, I don't know, 2? It ain't gonna happen. It ain't gonna compile, right? Why? Because I set it to be final. This is the type of variable, double. If you've seen these before, it just means that it's a floating point number, right? A fractional number, 3.5, 10.0, right? Negative 3.5, or in this case, 1.60 ... The other types are going to be integers, which are whole numbers. And then you can't do that, right? Because 1.6 is not a whole number. All right? So there's the equivalent in Java. A final double KMS per mile. And then you can use it anywhere you want. Okay? What's the next thing that we see? The main. Right? Every program has to have a starting point. Right? When you execute a program, it starts. Hopefully, eventually, it ends. Right? Some programs you don't want to end. Right? Some programs, like an operating system, you just want to go to sleep. Of course, you can shut down your computer entirely, in which case you have shut down that program. But if it's a server, you want your servers up 24/7 as much as possible. So you want some programs not to end. But all the programs that we'll do in this class, you want them to end. If they don't end and they just are sitting there cycling, you have what's called an infinite loop. Right? But the main entry point is the main part, is where it starts. Right? In C, that looks like this. Don't worry about argc and argv yet. Those are arguments. The count, the number that was provided, the v, the vector, the actual arguments. You have the same exact thing over here. And instead, it's just called args, right? Instead of two different things, argc and argv. Right? Then what do we do? What am I doing on line 14? I'm what? I'm declaring variables, right? Both languages, when you create variables, you have to declare them, their name and their type, right? What type of variable was this again? Double. It's a floating point number, right? We'll get into the details of what they can hold here on Friday. But I've called it miles and KMS. What if instead I'd called them something else, like double M and K? In the context, maybe you understand that they're miles and kilometers, but without context, if you just looked at this line, would you know what those variables are standing for, or what they represent, what they model? No. Those are terrible variable names. What if instead I did variable 001, variable 002? I need another variable, variable 003. Are those descriptive names? Are you going to know what they are? No, 50 lines down, and you're multiplying variable A of 001 by variable 003. What the hell is that result? Right? Those are terrible variable names. These are good variable names. Why? They tell you what they represent. Miles represents miles. You can create multiple variables using a comma. You could do it on multiple lines if you want, KMS, but you can compactify your code a little bit here by simply providing a list. Now, here's where the art comes in, right? You always have the Goldilocks dilemma, right? Not too hot, not too cold, right? You just right. KMS. If I wanted to go full description, I would go kilometers. There we go. Right. So which is better, kilometers or KMS? That's where you're getting into we can argue about it and we can debate about it, right? In the context, KMS is probably fine because you already read the purpose up here. This basic program converts miles to kilometers, right? In the context, KMS is pretty clear, right? Now, do we name our variable pi the ratio of the perfect circle's circumference to its diameter? Did I name it that sentence? No. I shortened it up to pi, right? Just like all mathematicians do. because in the context of mathematics, it's understood what that is. I have no idea what E is. Exponent, I assume? But exponential, basically, right? That's the natural exponential, right, et cetera. But other contexts, SSN, what would that mean? Social security number, probably, right? And UID. We understand that context because we're all in the NU system, right? Nebraska University ID identifier, right? If you took that same acronym and moved it over to, I don't know, I was at Amherst this summer, right, Massachusetts, they wouldn't, what the hell are you talking about, right? So it all really depends on the context, right? If the context says, yeah, that's probably okay, then fine. When in doubt, you're not, you're not being charged by the number of characters you write, right? Just go ahead and write it out, right? Stay away from, stay away from things that don't have a clear and present meaning, right? Definitely don't use X and Y unless you happen to be doing some coordinate stuff, right? And then in which case, is there any other name for the X-axis? No, all right? Unless you're graphing something and it's like time to money or something like that. And then, yeah, use those names because then the X-axis and the Y-axis, those demand labels, right? But if it's just a generic coordinate system of I need to go from point A in the Euclidean plane over to point B in the Euclidean plane, X and Y is probably fine, right? I've declared those variables and I've given them a type. If I try to assign those variables values, miles is equal to 10.5, right? Is that going to work? Yeah, because it's a fraction. Will that work? Yeah, because it's also a fraction. It's just 10.0, right? But if I have a different type of variable, int x, right, and I try to set it to 10.5, Java is going to complain about that, right? Why? This is a box that holds integers. Integers are whole numbers, right? And including negatives, so negative 10, negative 9, dot, 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 0, 1, 2, 3, 4, off to infinity. Although you cannot hold infinite size numbers, right? We'll talk about the limitations on Friday. 10.5, does that fit in a box for only whole numbers? Nope. So how can we make it fit into the box for only whole numbers? We have to get rid of the fractional part, and then it's okay. If I did that in C, it would do it for me. The compiler would just say, okay, well, you meant to do it, so that's what I'm going to do. I'm going to take that, I'm going to take that fraction and I'm going to throw it off. That's called truncation, right? C will let you do that, and that's the behavior in C. If you try to say this integer is equal to 10.5, I'll take the integer part, and that's it, right? The 0.5 gets thrown away. It's not rounded up, it's not rounded down, it is just simply thrown away. That's called truncation. In Java, they don't allow you to do that explicitly, right? They allow you to do it implicitly by saying, no, 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 go ahead and cut off that part. Treat it as an integer so that you can put it into an integer, right? Just something you have to, that's one of the, yet another difference between the two languages, right? Nuance. All right, what's next? We, as we already read, prompt the user for input. And how do we do that in C? Printf. Whatever we put inside of this of these double quotes right here, that's what gets printed, right? If I go and change this, of course I would have to recompile it. That's what would get printed. All right, that's pretty straightforward. Output, printf. The other part of that, IO, input, is going to be scanf. We're going to scan the standard input. The standard input is your keyboard. You sit there and mash the keyboard, that's the standard input. It's going to read from that. This is a little bit different here. This is called the formatting the placeholder. %LF stands for long floating point number. Remember that we're going to read in, we prompted them for miles, so we're going to read in miles from the user. They can enter 10 miles, they could enter 20 miles. They could enter -5 miles. Does that make sense? Maybe, I don't know. But they could also enter in 5.5 miles. Should we allow them to do that? Absolutely, right? I would want to convert 5.5 miles to kilometers, right? And so we need a placeholder to say that this is going to be a long floating point number. If we were reading in an integer instead, it would be D. If we were reading in a character instead, it would be C. We'll cover all that in detail on probably Friday. Right? We also need to read the input into a particular variable. In this case, it's miles. What is that thing right there? Ampersand. What does it mean? Hold that thought. We'll get to it eventually. Right? If you want to preview, that is getting the memory address of that variable so you can pass it by reference so that the function scanf can put a value into it. Don't worry about it. Just know that if you use printf and you print a variable, no ampersand. If you use scanf and read a variable for now, you gotta have an ampersand there. Right? Your compiler will tell you if you don't. If you forget that thing right there, here, GCC, hopefully it does. Yep, there we go. So it complains about this. %lf expects an argument of type double star, but it is of type double. Did you mean to do something there, right? Did you mean to put an ampersand there? And it's warning you about that. In fact, it's just a warning, right? Yeah, it's a warning. It lets you do it. Right? Go ahead and do that. What do you think happens when I try to run the program? Not that. Let's try to run that program now. It's going to prompt me for miles. 100 miles. What do you think is going to happen? Ah, it did. Darn it. Shouldn't have done that. I'm getting away with it for a reason, and I know the reason. Anyway, what I expected there to be would be what's called a Seg fault, right? A segmentation fault. I'm trying to access memory that doesn't belong to me. Again, put that in the back of your minds, and we'll revisit it later in detail. Right? For now, just understand you gotta have that ampersand there. Right? With our final 3 minutes here, how do I do the same in Java? How do I read input from the user for them mashing the keyboard down here in the console? Scanner. S is equal to new scanner. And I need to read the system.in. Oops. What do you think in stands for? Input. Just like you have, say, system.out.println. The out is output, right? The standard output. Usually, when you're importing something, it'll have some suggestions here. Make sure that you are choosing the right suggestion, and this is the right suggestion, where we're bringing in the scanner so that we can use it. Right? Now that just creates a scanner. How do I actually scan somebody mashing the keyboard there? S is equal, or not S, but miles is equal to S dot next double. If I expected them to read in an integer, it would be S dot next int. Right? If I wanted to read in a string, I think it's just not next, right? Et cetera, et cetera. I actually want a double here, so next double. I guess I never prompted them. Help me out. How do I prompt them for input? System.out.println. Enter miles, please. We'll be polite about it. What's the difference between ln and print? Whether or not it puts an endline character at the end. You can do it manually. You can let ln take care of it for you. Or you can just go ahead and copy over that C code and use printf as well. Right? It does not print an endline character for you. It'll look like this. Right? So eventually when we look at those placeholders and printing stuff, everything that you understand and see can be then ported right over to Java. Let's run this really quick and see what it looks like. 100. There we go. It ended. How do I know that it ended? There's no stop sign down here. There's no stop button, right? Let's run that again. Before I hit enter here, 100, that's the standard input. That's why it's green, right? There's a stop button right here that says that the program is continuing to run, right? It's sitting there waiting for me. It's waiting for me to enter the input and then hit return. Only then does it go back and start and get that actual value there. One more time. But instead of 100 being a nice, good user, I'll be an ID10T user. Huh. Write that out. We know what that is, right? ID10T user, right? ID 10T user. Idiot, right? So this idiot has mashed their keyboard and not entered a number of miles. What's going to happen? An exception, an error, right? What's going to happen over here, do you think? Let me go ahead and recompile it. Different, but same, right? Not the correct results. I mean, it is the correct results. 0 miles is equal to 0 kilometers, but did I enter 0? Nope. I entered blah, 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 blah. What was it actually? A, right? The way that the scanning works on the input in C is it looks at what you wrote and sees A. That ain't no number I ever heard of. So what have I read so far? Nothing. What's the equivalent? What's the numerical equivalent of nothing? 0, and that's what you get. All right. We'll pick it up there next time.